All right, now we get to cover migrations, uploads, and transfers in cloud storage. Let's talk about the transfer appliance, which is GCP's offering for large-scale one-time data transfers. The way it works is first you order the transfer appliance from GCP. This device is shipped to you. Then you fill the appliance, which basically means you connect it to your systems and you load your data onto it. This is probably your on-prem system. Next, once your data is loaded, you ship the appliance back to Google Cloud. After that, Google Cloud uploads your data into cloud storage, and it uploads it into specifically a bucket that you have designated. Your data is uploaded securely by Google and very efficiently to the cloud, from one of their data centers. And so it's ready to be accessed at that point. Finally, you can verify that your data has been successfully uploaded, and you can start using it as needed in the cloud once you finish verifying that it was uploaded correctly. Now, focusing on the key points here about the transfer appliance, essentially it is a good solution for large one-time data migrations, especially when your network bandwidth is limited. You want to consider it when you are moving data on the order of petabytes. It allows you to do so efficiently and securely, making it ideal for situations where data transfer over the internet is not practical. Let's talk about Storage Transfer Service, which is a managed service that simplifies moving data between clouds or from on-prem environments to Google Cloud Storage over the internet. So this is different from Transfer Appliance, obviously, in that you're actually using the internet. You're not loading your data onto a device and sending that back to Google. So Storage Transfer Service allows for you to move data to or from other clouds like AWS and Azure. This is great for scenarios where your data might currently live in other cloud providers and you want to transfer it to GCP, or vice versa. It's also good for moving data from on-prem to GCP. This is useful if you have data stored in your own file systems, your own data center, and you want to transition it to the cloud for better accessibility and scalability. Storage Transfer Service is also good for automating ongoing or scheduled transfers, which is a common use case. You can schedule transfers between sources without manual intervention with the Storage Transfer Service. One thing to note as well is that you will need a high bandwidth and a stable connection, and this is where the decision between Storage Transfer Service and Transfer Appliance kind of starts to come into play. At least 100 megabits per second is recommended, but 1 gigabit per second is actually preferred, and this would ensure smooth and quick transfers. Even at that speed, it's possible that you have too much data to use Storage Transfer Service with, and we will talk later in this presentation about how to calculate that. If you don't have a really good connection and you have a lot of data, you probably want to consider Transfer Appliance instead. And then Storage Transfer Service in general is recommended for data up to hundreds of terabytes. So if you're dealing with even larger volumes, that is also when you could consider Transfer Appliance instead. There's a gray area between kind of hundreds of terabytes and the petabyte range where it depends really on your network bandwidth. If you have really, really good internet, it's potentially okay to use the Storage Transfer Service, but again, it comes down to the exact numbers and you kind of have to calculate that. So you might get a question on the exam that essentially asks you to choose between them, Transfer Appliance or Storage Transfer Service, given the amount of data and internet bandwidth. So we'll go over how to calculate that. When we're thinking about transferring data with Storage Transfer Service, especially over the internet, it's important to know how long a transfer might take. So you may have to do this for a question on the exam too, at least being able to kind of estimate it. The formula for calculating the time required is simple. It is transfer time in seconds equals the data size in bits divided by the bandwidth in bits per second. So you really want to be figuring out what the transfer time in seconds is, because then you can figure out if it's practical. So this formula helps you estimate whether transferring data over the internet using storage transfer service is practical, given your network conditions. Let's walk through the steps to apply this formula. First, we need to convert our data size to bits. This is because bandwidth is measured in bits per second, and we want to keep our units consistent. For reference, 1 megabyte is about 8 million bits. 1 gigabyte is about 8 billion bits. 1 terabyte is about 8 trillion bits. And 1 petabyte is about 8 quadrillion bits. Alternatively, just remember that each unit higher is about 1,000 times bigger than the one before it. And as the last step in the conversion, there are 8 bits in a byte. So next, in step 2, we need to convert the bandwidth to bits per second. And this lets us figure out how much data we can transfer each second. For instance, 1 megabit per second is about 1 million bits per second, and 1 gigabit per second is about 1 billion bits per second. So again, there's a little bit of a shorthand here. You can just remember that each higher unit is about 1,000 times bigger than the one before it, and that will give you a good approximation. Once you do these 2 steps, you can then divide the data size by the bandwidth to figure out how long the transfer will take. So this is how you determine how long it will take to transfer data given the size of the data and the internet connection. Now, if we look at an example, this becomes a little bit more clear. Let's say you have 300 gigabytes of data and a 10 megabit per second internet connection. How long would it take for you to transfer your data to GCP over the internet? Step 1, we start by converting the data size to bits. Since 1 gigabyte is about 8 billion bits, we multiply that by 300, which gives us approximately 2.4 trillion bits. Step 2, we convert the bandwidth to bits per second. Since 1 megabit per second is about 1 million bits per second, 10 megabits per second would be about 10 million bits per second. And then we get to divide them. And so 2.4 trillion bits divided by 10 million bits per second equals 240,000 seconds. And then you convert that to hours, and 240,000 seconds is around 67 hours. So given this amount of data and this bandwidth, transferring the data over the internet would take 67 hours, which is almost 3 full days, and that's probably impractical. So in this situation, you would likely want to order the transfer appliance and move the data that way. It would be more efficient that way. You can also upload data to cloud storage using command line tools, gcloud and gsutil. Both tools allow you to upload files and directories, but they have slight differences in their syntax. And you may be asked about a scenario on the exam where you are using one or the other and you kind of need to make it go faster, or you need to pick the right command. Starting with gcloud, here are the commands. For a single file, you would use this, gcloud storage cp, and then the local file and the destination bucket. If you want to upload an entire directory, you would add the R flag, which recursively copies it. For gsutil, the process is very similar, but the commands differ slightly. To upload a single file, you would use gsutil cp. And for directories, again, you would add the R flag for recursive copying. So both tools are efficient, and this is just a comparison of how you do the same action with each. Now, a technique that you may use while you are performing those uploads is called partitioning. So especially when dealing with large data sets, splitting files into smaller segments and using concurrent upload jobs can significantly speed up the upload process. This applies whether you're using gsutil, gcloud, or storage transfer service. In particular, GSUtil has a feature called parallel composite uploads, which automatically breaks larger files down into smaller parts and uploads them in parallel. So this is really convenient, and it's a great way to optimize the upload process when working with massive files. For example, if you wanted to upload a large file, say over 100 megabytes, you could set a threshold with this command to enable parallel composite uploads, which tells GSUtil to break the file into parts with a threshold of 100 megabytes and upload them simultaneously, making it faster and more efficient. So definitely know that for the exam. And then additionally, on the topic of data transfers to cloud storage, another thing to know about is compression. Compressing files, like using gzip, can greatly reduce the size of your data, and that speeds up the transfer times. It also cuts down on storage costs, actually, because the files themselves take up less volume. This isn't something that you always need to do, but in cases where you're handling large amounts of data or you're dealing with cost-sensitive use cases, compression can make a difference. And then thanks to decompressive transcoding, there's actually no real downside to using compression for storage in cloud storage, because with this feature, cloud storage actually automatically decompresses gzip compressed files when they are served to the user, while still storing them in their compressed state. So you get the benefit of smaller storage costs without sacrificing the user experience. So you're saving on both storage and transfer costs without any additional complexity or impact to the end user, which is pretty cool. Now, we've already discussed 403 errors occurring with signed URLs, and you may encounter the same error during long-running data transfers to cloud storage. So you should know about it in this context as well. In this case, a 403 error, again meaning forbidden, usually happens when your credentials stop working. This is often due to temporary access tokens that have likely expired during the transfer. So to address this, there are a few steps that you should take. Regenerate the credentials so that they are valid again. Extend the longevity of the credentials if possible to prevent them from expiring too soon. And if you're transferring a large amount of data, consider splitting the transfer into smaller chunks. This reduces the likelihood of credentials expiring during a long transfer process. By managing the longevity of your credentials and using smaller chunks, you can prevent this 403 error from happening and ensure smoother data transfers. All right, that's it on migrations and transfers to cloud storage.